There's something profoundly humbling about staring up at the night sky, isn't there? For centuries, humanity has looked to the stars with awe, convinced we've unraveled their secrets, only to be proven wrong again and again. The universe has a way of defying our expectations, revealing mysteries that leave even the brightest minds speechless. Think about it. Every time we believe we've pinned down the rules of the cosmos, something extraordinary comes along to remind us just how much we have yet to discover. Take the moment astronomers spotted a planet drifting alone through the void, untethered to any star, a rogue world wandering the darkness, or the eerie, repeating signals from deep space that pulsed with such precision. Scientists briefly wondered if they were hearing from an intelligent civilization. These aren't just curiosities, they're cosmic curveballs that rewrite textbooks and force us to rethink our place in the universe. And the most thrilling part, these discoveries aren't relics of the past. Right now, as we speak, telescopes and probes are uncovering new anomalies that challenge everything we thought we knew. That's exactly what we're diving into today. 20 of the most astonishing astronomical discoveries that left scientists stunned. Each one is a reminder that the universe is far stranger, more dynamic, and more mysterious than we could have imagined. We'll explore celestial oddities that defy explanation, meet the researchers who dared to question the status quo, and uncover how these breakthroughs have reshaped our understanding of space itself. So if you've ever gazed up at the stars and felt that tug of wonder, that insatiable curiosity about what lies beyond, you're in the right place. Buckle up, because this journey through the cosmos is about to take some unexpected turns. Let's begin with one of the most baffling cosmic mysteries in recent memory, Tabby's star. Officially known as KIC 8462852, this unassuming star in the constellation Cygnus became an overnight sensation when astronomers noticed something downright bizarre. Its light was flickering unpredictably, dimming by staggering amounts, up to 22% at times, in ways no ordinary star should. Imagine a streetlight that suddenly dims to a faint glow, then brightens again with no clear reason. Now picture that happening on a cosmic scale. At first, scientists scrambled for explanations. Could it be a swarm of comets passing in front of the star, blocking its light? Maybe a vast cloud of interstellar dust, but the more they studied it, the weirder it got. Natural explanations didn't quite fit the data. The dimming was too extreme, too irregular. That's when whispers of a more radical idea surfaced. What if we were seeing evidence of alien technology? Some speculated about a Dyson sphere, a hypothetical megastructure built by an advanced civilization to harvest a star's energy. The idea sent ripples through the scientific community, sparking headlines worldwide. But here's the twist: despite years of scrutiny, Tabby's star still refuses to give up its secrets. New observations suggest the dimming might come from uneven dust clouds or even remnants of a devoured planet, yet no single theory explains every oddity. What makes this star so captivating isn't just the mystery itself, but what it represents. It's a humbling reminder that even in our own galactic backyard, nature can still surprise us in ways we never anticipated. And that's just the beginning of our journey through the cosmos's greatest enigmas. Just when we thought Tabby's star had stretched our imaginations to the limit, the cosmos delivered another curveball, this time from beyond our solar system. In October 2017, astronomers spotted something unprecedented. A strange, speeding object hurtling past the sun on a trajectory unlike anything seen before. They named it Oumuamua, a Hawaiian word meaning scout or messenger from afar. And what a messenger it turned out to be. This wasn't just another asteroid or comet from our own solar system. It was the first confirmed visitor from interstellar space. Right away, Oumuamua stood out for its bizarre shape. Unlike the roughly spherical objects we're used to seeing, this thing was long and thin, some estimates suggested it could be up to 10 times as long as it was wide. Picture a cosmic cigar tumbling through the void, but the real shock came when scientists tracked its movement. Instead of slowing down as expected under the sun's gravity, Oumuamua sped up slightly, as if pushed by an unseen force. Comets often accelerate like this when their icy surfaces vaporize, creating a visible tail of gas and dust. Yet Oumuamua showed no such tail. It was as if the universe had thrown us a riddle wrapped in an enigma. Theories exploded. Could this acceleration be caused by hidden pockets of gas erupting from its surface? Maybe hydrogen ice, invisible to telescopes, was turning directly from solid to gas in the warmth of the sun. Some researchers even floated the possibility, however slim, that Oumuamua wasn't a natural object at all. The lack of a visible tail, combined with its peculiar shape, led a few scientists to speculate about artificial origins, like a discarded piece of alien technology or a solar sail from another civilization. But here's the thing, while the exotic explanations grabbed headlines, the most plausible answers were far more mundane, yet no less fascinating. Further analysis suggested Oumuamua was likely a fragment of a Pluto-like world, sheared off in some distant cataclysm and sent hurtling across the galaxy. Its strange acceleration might have come from outgassing we simply couldn't detect, or even the gentle push of sunlight itself nudging its elongated form. What makes Oumuamua so extraordinary isn't just its mystery, it's the door it kicked open. Before this, we had no proof that interstellar objects could reach us at all. Now we know the universe is constantly flinging debris across the cosmic void, and some of it passes right through our backyard. It's a reminder that space isn't just vast, it's dynamic, unpredictable, and full of surprises we're only beginning to uncover. And if Oumuamua was the first interstellar visitor, one thing's certain, it won't be the last. If Oumuamua showed us how bizarre interstellar visitors can be, fast radio bursts proved the cosmos has even stranger ways to get our attention. Picture this, a pulse of radio waves lasting just milliseconds, but packing more energy than the sun emits in days. When astronomers first detected these fleeting signals in 2007, they assumed they were witnessing cosmic one-off events colliding neutron stars, perhaps, or black holes swallowing dying stars. But then, in 2016, everything changed. That's when researchers caught something unprecedented. A fast radio burst that didn't just flash once, it kept coming back. This repeater, officially named FRB 121102, shattered every expectation. Unlike the singular bursts we'd seen before, this one flickered on and off like a celestial lighthouse, sending out over 100 distinct signals since its discovery. Suddenly, the old theories fell apart. If these bursts were caused by catastrophic, one-time events, how could one source keep producing them? The answer seemed to lie in something far more exotic. Magnetars, ultra-dense neutron stars with magnetic fields so intense, they could strip the information off a credit card from halfway across the Milky Way. Here's where it gets even weirder. In 2020, astronomers witnessed something astonishing, an FRB originating right inside our own galaxy, linked definitively to a known magnetar. For the first time, we had proof that these bizarre stars could produce the signals. But here's the twist, the energy from this nearby burst was far weaker than those coming from deep space. So while magnetars might explain some FRBs, they can't account for the most powerful ones, which seem to emerge from galaxies billions of light years away. That leaves us with a tantalizing gap in our understanding. Could there be multiple types of FRBs, some from magnetars and others from even more extreme phenomena? Some scientists speculate about cosmic strings, primordial black holes, or dare we say it, signatures of advanced civilizations. What makes these repeating bursts so thrilling isn't just their mystery, but what they reveal about the universe's creativity. Out there in the darkness, forces we can't yet fathom are at work, bending the rules of physics and reminding us that the cosmos still holds cards it hasn't shown us yet. And with every new detection, we're one step closer to figuring out just what's sending these cryptic messages across the void. Just when we thought black holes couldn't get any more mysterious, the universe delivered GW 19021, a collision so bizarre it rewrote the rulebook. In May 2019, the Laser Interferometer Gravitational Wave Observatory, or LIGO, picked up ripples in spacetime from a cataclysmic event over 7 billion light-years away. The signal told the story of two black holes spiraling into each other, merging into one. But there was a problem. One of those black holes weighed in at a staggering 85 times the mass of our Sun, and according to everything we knew, that shouldn't have been possible. Here's why this blew astronomers' minds. Black holes typically form when massive stars collapse under their own gravity at the end of their lives, but there's a cosmic sweet spot for this process. Stars between about 65 and 130 solar masses don't just collapse, they undergo something called pair instability, where their cores become so hot that matter and antimatter particles annihilate each other in a runaway explosion. The result, the star obliterates itself entirely, leaving nothing behind. No black hole, no remnant, just stardust scattered into the void. So how did GW 19021's 85 solar mass black hole exist at all? It was like finding a mountain where the laws of physics said only a valley could be. Theories immediately began swirling. Maybe this was a second-generation black hole, born from an earlier merger of two smaller ones. Imagine two black holes, each around 40 solar masses, colliding in some ancient corner of the universe. Their fusion would create a single object right in that forbidden mass range, an impossible child of an earlier cosmic dance. Or perhaps this black hole didn't form from a dying star at all, but emerged straight from the chaos of the early universe, a primordial relic from a time when matter was denser and the rules were different. But the surprises didn't stop there. The merger itself defied expectations. When the two black holes finally combined, the resulting behemoth clocked in at 142 solar masses, plunging straight into another theoretical no-go zone, intermediate mass black holes. These elusive objects, bigger than the stellar mass black holes we're familiar with, but smaller than the supermassive giants lurking in galactic centers, have been notoriously hard to find. Their existence has been debated for decades, and GW 19021 might have handed us the first direct evidence. What makes this discovery so groundbreaking isn't just the mystery it presents, but the doors it kicks open. If black holes can form outside the usual stellar collapse channels, what else have we been missing? Could the cosmos be hiding entire populations of black holes born through exotic processes we haven't even imagined? Every time we think we've figured out the rules, the universe reminds us it's still playing by its own. And with gravitational wave astronomy still in its infancy, one thing's certain: the next detection could upend everything all over again. Imagine an entire galaxy, vast, sprawling, and nearly invisible. No glittering stars, no luminous gas clouds, just a shadowy structure drifting through the cosmos like a ghost. That's exactly what astronomers stumbled upon in 2016 when they discovered Dragonfly 44, a galaxy that defies everything we thought we knew about how these cosmic giants form. At first glance, it seemed ordinary enough, nestled in the Coma cluster about 330 million light-years away. But when researchers calculated its mass, the numbers didn't add up. Dragonfly 44 weighed as much as our Milky Way, yet it emitted less than 1% of the light. Where was all that missing mass? The answer shook the foundations of astrophysics. This was a galaxy made almost entirely of dark matter. Dark matter, the elusive, invisible substance that makes up roughly 27% of the universe, had always been thought to work in tandem with ordinary matter, weaving the scaffolding for galaxies to form. But Dragonfly 44 flipped that idea on its head. Here was a galaxy where dark matter wasn't just the support structure, it was the entire show. The few stars it contained were like lonely flecks of dust in an otherwise empty warehouse, drifting through a space dominated by something we can't even see. The discovery sent scientists scrambling. How could such a thing exist? Current models suggest galaxies start as clumps of dark matter whose gravity pulls in gas and dust, eventually sparking star formation. But Dragonfly 44's dark matter halo was so massive, it should have attracted far more visible matter. Did something prevent stars from forming? Was the gas stripped away by collisions with other galaxies? Or does dark matter behave in ways we haven't even begun to understand? Then came the real kicker. Dragonfly 44 might not be alone. Surveys have since hinted at other ultra-diffuse galaxies with similarly bizarre properties: faint, star-poor, yet inexplicably heavy. Some researchers speculate these could be failed galaxies, places where star formation somehow stalled, leaving behind eerie dark matter husks. Others wonder if they're remnants of galactic collisions, their stars scattered while their dark matter cores endured. What makes these shadowy giants so revolutionary isn't just their strangeness, it's the questions they force us to confront. If dark matter can build entire galaxies without stars, what else is lurking in the darkness? Could there be vast, invisible structures weaving through the cosmos, completely undetectable to our telescopes? Dragonfly 44 isn't just a cosmic oddity. It's a beacon illuminating how much we still have to learn about the hidden forces shaping our universe. And with every new discovery, the line between the known and the unknown grows fainter, just like the stars we're only beginning to see. HD 106906b isn't just an oddball planet, it's a cosmic rebel that refuses to follow the rules. Picture a world 11 times more massive than Jupiter, orbiting so far from its star that a single year there lasts 15,000 Earth years. At 737 astronomical units out, that's over 70 times farther than Pluto is from our Sun. This gas giant exists in a realm where planets simply aren't supposed to form. Theories suggest planets are born close to their stars, coalescing from spinning disks of gas and dust. Yet here's HD 106906b, lingering in the frigid outskirts of its system like a guest who wandered into the wrong party and somehow found a seat at the table. The mystery deepens when you consider how it got there. One leading idea is gravitational chaos. Maybe this planet was born closer to its star, only to be violently flung outward by a close encounter with another massive object, a stellar dance gone wrong. But here's the catch: if that happened, the planet should have been ejected entirely, lost to interstellar space. Instead, it clung to its distant orbit, a cosmic Houdini defying the odds. Some astronomers wonder if a passing star might have stabilized its path, acting like a gravitational anchor to keep it from drifting away forever. Others speculate that HD 106906b didn't form like a traditional planet at all, but instead collapsed directly from a clump of gas in the outer disk, bypassing the usual rules entirely. What makes this discovery so tantalizing isn't just the puzzle of its existence, it's the shadow it casts on our understanding of planetary systems. If a planet can survive, let alone form, in such extreme conditions, what else might be lurking in the outer darkness of other star systems? Could there be an entire population of these rogue giants, invisible to our telescopes until they betray their presence through subtle gravitational tugs? HD 106906b forces us to confront the gaps in our knowledge, reminding us that the universe is far stranger than our textbooks suggest. And as we peer deeper into the void, who knows what other rule-breaking worlds might be waiting to challenge everything we think we know. If you thought neutron stars were already extreme, Wait until you meet PSRJ 1748-2446 AD, the cosmic equivalent of a figure skater pulling off a spin so fast it defies the laws of physics. Clocking in at a mind-blowing 716 rotations every second, this pulsar holds the record for the fastest spin ever observed in nature. To put that in perspective, imagine a city-sized object packed with more mass than our Sun completing a full rotation in less time than it takes to blink twice. At that speed, its surface is whipping around at nearly a quarter the speed of light, a velocity so staggering it should, by all known physics, rip the star apart. Yet somehow it holds together, leaving scientists scrambling to explain how such a thing is even possible. The mystery lies in the very nature of neutron stars. These incredibly dense stellar corpses are what remain after a massive star explodes in a supernova, collapsing into a sphere just 12 miles across, but with gravity so intense, a teaspoon of its material would weigh 1 billion tons on Earth. Normally, the rotational speed of a neutron star is limited by its own density. Spin it too fast, and centrifugal forces would overcome gravity, flinging its outer layers into space. Based on our current understanding, PSRJ 1748-2446 AD shouldn't exist. Its rotation rate pushes right up against the theoretical maximum, a boundary known as the mass shedding limit, where matter at the equator should be hurled into the void. So why hasn't this pulsar torn itself to shreds? One possibility lies in its bizarre internal structure. Some theorists suggest this pulsar's core might be made of an exotic state of matter, a hyperfluid soup of quarks or other particles behaving in ways we've never observed in labs. This could allow the star to deform slightly under rotation, redistributing mass to stabilize itself against destruction. Others speculate it might be surrounded by an invisible cocoon of magnetic fields, acting like cosmic duct tape to hold the star together. Then there's the wild card. What if our models of neutron star physics are missing something fundamental? What makes this discovery so thrilling isn't just the scientific puzzle, it's the implications. If a pulsar can spin this fast without disintegrating, what does that say about the true nature of matter under extreme conditions? These observations might hold clues about the behavior of quarks, the existence of hypothetical particles, or even the limits of Einstein's theory of relativity. Every time we think we've reached the edge of what's possible, the universe hands us an exception, daring us to rethink the rules. And as telescopes grow more powerful, who knows what other cosmic speed demons might be lurking in the darkness, waiting to challenge everything we thought we knew. The universe is full of vast structures, galaxies, clusters, superclusters, all woven together in a sprawling cosmic web. But what if I told you there's a place where that web unravels into nothingness, a void so enormous it could swallow thousands of galaxies without a trace? Welcome to the Boötes Void, a staggering emptiness stretching 330 million light-years across, a place astronomers call the Great Nothing. At first glance, the Boötes Void shouldn't exist. Our best models of the universe predict matter should be distributed relatively evenly, with galaxies clustering like cities connected by highways of dark matter. Yet here's a region where the cities are almost entirely absent. To put its scale into perspective, if you place the Milky Way at one edge of the void, the nearest major galaxy on the other side would be so far away, its light would take hundreds of millions of years to reach us. And in between, nearly nothing, just a handful of lonely galaxies adrift in an ocean of darkness, like a few scattered pebbles in a desert the size of a continent. Theories about how this void formed range from the plausible to the mind-bending. One idea suggests it's the aftermath of ancient cosmic collisions, not between galaxies, but between entire universes. In the multiverse hypothesis, our universe might have bumped against a neighboring one in the distant past, their interaction clearing out matter like a celestial plow. Others propose it's the work of a phenomenon called quantum tunneling, where vast regions of space underwent a phase shift early in the universe's history, leaving behind these eerie blank spots. But the most unsettling possibility, the Boötes Void, might not be alone. Astronomers have identified other voids, though none as strikingly empty as this one. Could these voids be evidence of something fundamental we're missing about the universe's structure? Or are they cosmic fossils, preserving clues about forces that shaped reality in ways we can barely imagine? Every time we point our telescopes at these abysses, we're confronted with the same humbling truth. The universe isn't just vast, it's full of puzzles we've only begun to notice. And lurking in those gaps might be answers to questions we haven't even thought to ask. We've grown accustomed to moons being the smaller companions of planets' modest worlds like our own lunar neighbor or Jupiter's icy Europa. But in 2017, astronomers peering at data from the Kepler Space Telescope stumbled onto something that shattered those expectations. Orbiting a gas giant 8,000 light-years away, a colossal object designated Kepler 1625b1 appeared to be the first known exomoon, a moon outside our solar system. And this wasn't just any moon. If real, it would dwarf every satellite we've ever seen, rivaling the size of Neptune itself. The discovery sent shockwaves through the scientific community because by all accounts this shouldn't exist. Moons typically form in one of two ways. Either they're forged from the debris of planet-forming disks, like the moons of Jupiter, or they're captured by a planet's gravity, like Neptune's oddball moon Triton. But neither scenario easily explains how a Neptune-sized object could end up as a moon. Imagine trying to lasso a whale with a piece of string. That's roughly the scale of the challenge here. The gravitational mechanics alone would require an implausibly precise series of cosmic events. Then there's the matter of its orbit. Kepler 1625b1 circles its host planet at a distance 20 times farther than our moon is from Earth, another head-scratcher. Moons that large and distant should destabilize their parent planet's orbit or get ejected entirely. So what's keeping this cosmic oddity in place? Some theorists suggest it might not be a moon at all, but rather a binary planet, two worlds locked in mutual orbit, neither truly dominant. Others propose it could be the remnant of a catastrophic collision, a shattered world's core that was captured by the gas giant's gravity. But here's the twist: confirming its existence has been maddeningly difficult. Initial observations relied on the transit method, detecting dips in starlight as the planet and its potential moon passed in front of their sun. The data hinted at the moon's presence, but follow-up studies with the Hubble Space Telescope yielded conflicting results. Was it a moon, a glitch in the data, or something even stranger? What makes Kepler 1625b1 so captivating isn't just the mystery. It's the possibility that we've been thinking about moons all wrong. If something this massive can exist as a satellite, what other lunar extremes might be out there? Could there be moons larger than Earth, moons with their own moons? Every unanswered question forces us to reconsider the boundaries of what's possible, proving once again that the universe delights in defying our expectations. And as telescopes grow more advanced, one thing's certain: the hunt for impossible moons is only just beginning. Imagine a planet where the ground beneath your feet isn't rock or ice, but a glittering expanse of diamond stretching as far as the eye can see. That's not science fiction, it's the reality of 55 Cancri, a world so dazzlingly exotic it redefines the meaning of precious. Located 40 light-years away in the constellation Cancer, this super-Earth orbits so close to its host star that a single year lasts just 18 hours and surface temperatures soar above 2,000 degrees Celsius. But what truly sets this planet apart isn't its scorching heat or breakneck orbit. It's the fact that scientists believe it's literally made of diamond. The story of 55 Cancri begins with its star, which belongs to a rare class known as carbon-rich stars. Unlike our Sun, which has more oxygen than carbon, this star's composition skewed the planetary formation process in a radical direction. As the system took shape, carbon atoms bonded under extreme pressure and heat, crystallizing into vast sheets of diamond. Current models suggest the planet's interior could be a seething ocean of carbon, with a surface layer hundreds of miles thick made almost entirely of compressed diamond and graphite. Picture standing on a landscape where mountains aren't just diamond, encrusted, they're monolithic diamonds themselves. But here's the twist. This planet's existence challenges everything we thought we knew about planetary formation. Traditional models assume planets form from materials similar to our solar systems, silicate rocks and metals dominating the mix. 55 Cancri E throws that assumption out the window, proving that under the right conditions, carbon can become the universe's primary building block. Some astronomers speculate this world might even harbor layers of liquid carbon deep beneath its surface, a molten veneer that could behave like a metallic fluid, generating magnetic fields unlike anything we've seen. Yet the most fascinating question isn't just how this planet formed, it's what it tells us about the diversity of worlds we've yet to discover. If carbon-rich planets like this exist, could there be others with even more bizarre compositions? Imagine planets made of sapphire or entire worlds coated in layers of organic tar. 55 Cancri E isn't just a cosmic curiosity. It's a window into the infinite variety of planetary possibilities, proving that the universe's creativity knows no bounds. And as we keep searching, who knows what other jeweled wonders might be waiting in the dark? Black holes are often imagined as cosmic vacuum cleaners, stationary monsters lurking at the centers of galaxies, devouring everything that wanders too close. But what if I told you some of these giants are anything but stationary? In 2017, the Hubble Space Telescope spotted something that shattered that textbook image. A supermassive black hole weighing as much as 20 million suns racing through intergalactic space at breakneck speed. And it wasn't traveling alone. Behind it stretched a 200,000 light-year long trail of newborn stars, glowing like breadcrumbs marking the path of an unimaginably powerful cosmic fugitive. This wasn't just a black hole on the move, it was rewriting the rules. Supermassive black holes are supposed to sit firmly at the hearts of galaxies, their immense gravity anchoring entire spiral arms and star clusters in orbit. Yet here was one that had apparently been flung from its home, dragging a river of star-forming gas behind it like a celestial jet stream, the most plausible explanation. A violent game of galactic billions. When two galaxies collide, their central black holes eventually spiral toward each other, merging in a cataclysmic event that sends gravitational shockwaves rippling through spacetime. But if a third galaxy interrupts this dance, the complex interplay of gravity can slingshot one of the black holes away at incredible speeds, ejecting it into the void like a stone from a sling. What makes this discovery so extraordinary isn't just the spectacle, it's the unintended consequences. As the black hole plowed through clouds of gas, its sheer velocity created shockwaves that compressed the material in its wake, triggering the birth of countless stars. Normally, star formation is a slow, delicate process, but here it was happening in a frenzied chain reaction, painting a luminous streak across the darkness. It's a stark reminder that chaos isn't just destructive, it can be creative, sculpting new structures where we least expect them. And it raises an exhilarating question. If one runaway black hole can leave such a mark, how many other cosmic outcasts might be out there, silently shaping the universe in ways we've yet to discover? Galaxies are supposed to evolve spiraling arms sprouting new stars, collisions triggering bursts of stellar birth, aging populations fading into red giants. But what if you stumbled upon a cosmic fossil, a galactic artifact frozen in time? That's exactly what astronomers found in NGC 1277, a relic galaxy that hasn't just defied expectations, it's rewritten the rules of galactic evolution. Nestled in the Perseus cluster 220 million light-years away, this ancient island of stars looks almost exactly as it did 11 billion years ago, a snapshot of the universe's fiery youth preserved in the present day. What makes NGC 1277 so extraordinary is what's missing. Unlike modern galaxies brimming with young blue stars and glowing nebulae, this one is packed with old, red stars that formed in a frenzied burst shortly after the Big Bang then stopped. No new stars, no fresh gas, just a cosmic graveyard of ancient suns, untouched by the usual cycles of galactic renewal. It's as if someone pressed pause on this galaxy's evolution and walked away, leaving it suspended in time while the universe moved on around it. The mystery deepens when you realize how this relic survived. Galaxies grow by merging with others, absorbing gas and dust to fuel new generations of stars. Yet NGC 1277 has existed in near-perfect isolation, its outer halo stripped bare by the gravitational tides of its cluster environment. Without fresh material to feed on, star formation ground to a halt, preserving the galaxy in a pristine, primordial state. But here's the kicker. Our models suggest relic galaxies like this should have been incredibly rare even in the early universe, let alone persisting billions of years into the present. Finding one now is like stumbling upon a living dinosaur, something that by all accounts shouldn't still be here. Theories abound. Perhaps its location in the dense Perseus cluster shielded it from mergers, a cosmic quarantine that kept it pure. Or maybe its supermassive black hole, proportionally one of the largest ever found, acted like a gravitational bouncer, preventing new material from entering. Some scientists even speculate that relics like NGC 1277 could be the seeds from which today's giant galaxies grew, offering us a direct line to the universe's earliest structures. What's undeniable is the window this galaxy opens into a lost era. Every star, every wisp of dust in NGC 1277 carries chemical signatures from a time when the cosmos was young and raw. It's a living time capsule, challenging us to rethink not just how galaxies age, but how they're born. And with each new relic discovered, we're forced to confront an uncomfortable truth. The universe may have been building galaxies in ways we're only beginning to glimpse. The past isn't just history, it's still out there, waiting for us to notice. Of all the cosmic survival stories, none are more astonishing than the tale of GSN 069, a white dwarf that turned the tables on one of the universe's most unforgiving predators. Picture this, a black hole's gravitational grip is so relentless, even light can't escape it. Yet somehow, this stellar underdog didn't just get caught in a black hole's deadly embrace. It turned their encounter into an ongoing cosmic tango, flaring to life like clockwork every 9 hours. Astronomers watching this spectacle realized they weren't witnessing a one-time catastrophe, but a bizarre, repeating cycle of near destruction and rebirth that redefined what we thought possible. Here's how the drama unfolds. Every time the white dwarf swings closest to the black hole, tidal forces strip away a layer of its material, enough gas to cover 3 moons, sending it spiraling into the abyss. This stolen matter heats up to millions of degrees, erupting in a brilliant X-ray flare visible across the cosmos. But instead of being fully consumed, the star survives the encounter, swinging back out to a safer distance before returning 9 hours later to repeat the process. It's like watching a cosmic Sisyphus pushing a boulder up a hill, only for the boulder to roll back down over and over forever. What makes this discovery so mind-bending isn't just the star's resilience, it's the sheer improbability of the dance. Black holes aren't known for playing with their food. Normally, a star venturing too close gets shredded in a single, catastrophic event, a tidal disruption flare that marks its final moments. But GSN 069's black hole seems to be nibbling rather than gorging, taking just enough to trigger regular flares without delivering a death blow. Theories about how this delicate balance works read like a physics thriller. Some suggest the star's highly elliptical orbit keeps it from crossing the point of no return, grazing the black hole's danger zone without plunging in. Others speculate the white dwarf's dense, compact nature lets it withstand tidal forces that would rip apart a larger star. Then there's the wild card. Could the black hole itself be unusually gentle, with a feeding style we've never seen before? But the real magic lies in what this duet tells us about the universe's hidden rhythms. If one star can survive this gravitational gauntlet, might others be doing the same, hidden in the darkness? Could there be entire populations of stars locked in these precarious orbits, turning black holes from destroyers into unwilling partners in a cosmic ballet? Every flicker from GSN 069 forces us to reconsider the brutality and beauty of gravity itself, and the incredible ways life, even for a star, finds a way to cling on. Some planets don't play by the rules, and SIMP J01365663 plus 09333473 takes rebellion to cosmic extremes. This rogue world, drifting through space without a star to call home, should be a frozen, silent outcast. Yet somehow, against all odds, it's putting on one of the universe's most dazzling light shows, an aurora so powerful it outshines anything in our solar system. The catch: auroras need magnetic fields, and magnetic fields usually require a star's influence. So how is this lonely wanderer, barely larger than Jupiter, generating such spectacular displays all on its own? The discovery of SIMP auroras sent shockwaves through planetary science because it upends everything we thought we knew about how these phenomena work. On Earth, the northern lights occur when solar wind particles collide with our magnetic field, channeled toward the poles by our planet's rotation. Even Jupiter's auroras, the most intense in our solar system, rely partly on volcanic material flung into space by its moon Io, supercharged by the giant planet's rapid spin. But SIMP has none of these advantages. No stellar wind, no volcanic moons, just the cold, empty void. Yet its auroras blaze with a radio brightness 50 times stronger than Jupiter's, painting its lonely atmosphere with otherworldly colors we can only imagine. Scientists are racing to explain the mechanics behind this celestial anomaly. One leading theory points to the planet's turbulent interior. Despite its lonely existence, SIMP is anything but dormant. It's a cosmic furnace, still radiating heat from its violent birth, with a molten core churning beneath its cloud tops. This internal energy might be driving a dynamo effect, where swirling conductive material generates a magnetic field strong enough to rival a star's influence. Another possibility: the planet's sheer speed. Rogue worlds like SIMP often move at incredible velocities, and this motion through the galaxy's sparse magnetic fields could be sparking auroras through sheer friction, like a ship cutting through cosmic waves, leaving a trail of light in its wake. But here's the real mind bender. If one rogue planet can produce auroras this brilliant, how many others might be lighting up the darkness unseen? The universe could be teeming with orphaned worlds, each with its own invisible magnetic fingerprint, painting the void with color we've never detected. SIMP isn't just rewriting the rules, it's proving that even the loneliest places in the cosmos hold surprises, challenging us to rethink what it means to be a planet at all. And as our telescopes grow sharper, who knows what other luminous outcasts might emerge from the shadows, turning solitude into spectacle. For decades, black holes seem to come in just two sizes: stellar mass black holes, the remains of dead stars, and supermassive monsters anchoring galaxies. But where were the middleweights? The cosmic missing link remained frustratingly elusive until astronomers turned their gaze toward 47 Tucani, a dense globular cluster orbiting our Milky Way. Hidden among its ancient stars, they found something revolutionary: an intermediate mass black hole, roughly 2,000 times heavier than our Sun. This wasn't just another cosmic oddity. It was the smoking gun proving black holes grow in stages, bridging the gap between small and unimaginably large. What makes this discovery so groundbreaking is the way it defied expectations. Conventional wisdom said globular clusters, tightly packed relics of the early universe, shouldn't harbor black holes this massive. Their stars are so densely packed that any fledgling black hole should have been hurled out by gravitational chaos long ago. Yet there it was, lurking silently in the cluster's core, its presence betrayed only by the subtle way it influenced the orbits of nearby stars. Tracking those stellar motions required painstaking observations spanning years, like watching grains of sand shift in an interstellar hourglass. The implications are staggering. If intermediate black holes can form and survive in environments as hostile as 47 Tucani, they might be far more common than we ever imagined. Some could be the seeds of future supermassive giants, growing stealthily by swallowing stars or merging with smaller black holes over cosmic time. Others might be frozen in adolescence, trapped in clusters that strip away their feeding material too soon. This single discovery cracks open an entire new chapter in black hole evolution, one where growth isn't just a binary jump from small to enormous, but a complex journey with stages we're only beginning to map. Perhaps most tantalizing is what this means for gravitational wave astronomy. When LIGO detects colliding black holes, nearly all have been stellar mass. But what if mid-sized black holes are out there merging too, their crashes sending ripples through spacetime? Finding 47 Tucani's hidden giant suggests the universe might be buzzing with these events, hidden just beyond our current detection limits. It's a humbling reminder that even in well-studied corners of the cosmos, monumental discoveries wait patiently for us to look closer and ask the right questions. When a star dies, we expect fireworks, a brilliant supernova explosion that lights up the cosmos for weeks before fading into darkness. But in 2014, astronomers witnessed a stellar death so bizarre it turned this script upside down. Supernova PTF-14hls didn't just explode once. It erupted, dimmed, then flared back to life like a cosmic phoenix, not just once, but at least 5 times over 600 days, as if the star couldn't decide whether to live or die. This wasn't just unusual, it was supposed to be impossible. Normally, a supernova's light curve follows a predictable pattern, a sharp peak as the explosion tears the star apart, followed by a steady decline as radioactive debris decays. But PTF-14hls laughed in the face of convention. Its brightness yo-yoed erratically, at one point surging back to nearly full intensity a full year after its initial detonation. Even more puzzling was its spectrum, which showed hydrogen, something no Type II supernova should still possess months after exploding. It was like finding a corpse with a beating heart, defying every law of stellar mortality. Theories erupted as wildly as the supernova itself. Was this a pulsational pair instability event, where a behemoth star over 130 solar masses experienced violent convulsions, shedding layers in repeated eruptions before its final collapse? Or did it swallow a companion star, triggering staggered explosions as it digested its meal? Some even speculated about magnetar's ultramagnetic neutron stars injecting energy back into the wreckage like a defibrillator shocking a failing heart. But here's the real kicker. Buried in archival photos, researchers found evidence the same star might have survived another eruption in 1954. If true, this zombie star has been cheating death for decades, rewriting the rules with every resurrection. What we're witnessing might not be a supernova at all, but an entirely new class of stellar explosion, one that forces us to reconsider how the universe's most massive stars bow out. And with each new observation, one thing becomes clear. When it comes to stellar deaths, we've only scratched the surface of nature's creativity. Most stars drift through the galaxy at a leisurely pace, following predictable orbits like cars on a cosmic highway. But then there are the rule-breakers stars like S5HVS1, a blazing rebel clocked at over 4 million miles per hour, fast enough to cross the entire United States in under 2 seconds. This isn't just speed, it's escape velocity, a trajectory so extreme it defies everything we thought we knew about how stars move, and the culprit behind this celestial fastball. None other than the universe's ultimate power hitter, a supermassive black hole. Picture the scene: a binary star system wanders too close to the monster lurking at the heart of the Milky Way. The black hole's gravity seizes one star, dragging it into a lethal orbit while flinging its companion outward with unimaginable force, like a slingshot releasing a stone. The ejected star doesn't just meander away, it's hurled into the void at speeds that boggle the mind, leaving its doomed twin behind as cosmic collateral. This is no gentle nudge, it's a gravitational catapult capable of launching stars clear out of the galaxy itself. What makes hypervelocity stars like S5HVS1 so extraordinary isn't just their speed, it's the secrets they carry. By tracing their paths backward, astronomers can reconstruct violent encounters that happened millions of years ago, mapping the invisible fingerprints of black holes we've never directly observed. It's like finding an arrow embedded in a tree and realizing it was fired from a bow no one knew existed. These stellar fugitives are more than cosmic anomalies. They're messengers, revealing histories of galactic chaos written in their trajectories. And here's the twist: we're only seeing the survivors. For every hypervelocity star that escapes, countless others are torn apart or swallowed whole. That makes these speedsters the lucky ones, the rare few that got away, their blistering journeys serving as testimony to forces so powerful they can reshape the fate of entire stars. As we discover more of these cosmic outlaws, we're forced to confront a humbling truth. Even in the vast quiet of space, violence writes the rules and black holes hold the pen. Even the most confident scientific discoveries can turn to smoke before our eyes. Just ask the astronomers who watched in disbelief as Fomalhaut B, the so-called phantom exoplanet, literally vanished from sight. Back in 2008, this seemed like a watershed moment. Hubble Space Telescope images appeared to capture a planet orbiting the bright star Fomalhaut, a mere 25 light-years away. Not only was it one of the first exoplanets ever directly imaged, but it also occupied a dramatic position skirting the inner edge of a vast debris ring like a cosmic tightrope walker. The discovery made headlines worldwide, hailed as proof we could finally see alien worlds with our own eyes. But then something impossible happened. By 2014, follow-up observations showed the planet fading. By 2020, it was gone entirely, not just dimmed, but completely undetectable. This wasn't a case of faulty equipment or human error. Fomalhaut B had simply dissolved into nothingness, leaving astronomers scrambling for answers. How could a planet, a massive object bound by gravity, just disappear? The truth turned out to be stranger than fiction. Instead of a planet, scientists now believe they witnessed the aftermath of a catastrophic collision between two planet-sized bodies. The planet we saw may have been an expanding cloud of dust and debris, glowing faintly as it scattered light from Fomalhaut. Over time, those particles dispersed into the void, leaving no trace behind. Imagine watching a car crash in slow motion from hundreds of miles away. First, the violent impact, then a lingering dust cloud, and finally, empty road as the wind carries the evidence away. That's essentially what happened here, but on a cosmic scale. What makes this cosmic ghost story so compelling isn't just the mystery, it's the lesson it teaches about the universe's sleight of hand. For years, we thought we'd captured a planet red-handed. Instead, we'd stumbled upon something far more fleeting, a snapshot of destruction masquerading as a world. It's a humbling reminder that even our most advanced tools can be fooled by the cosmos' illusions. And as we keep searching the skies, one thing's certain: not everything that glitters is a planet. Sometimes it's just stardust spinning a tale we're only beginning to understand. Out in the constellation Monoceros, about 2,300 light-years from Earth, there's a cosmic shape so peculiar it looks like it was sketched with a ruler. Meet the Red Rectangle Nebula, a stunning anomaly where the usual billowing clouds of gas and dust give way to razor-sharp geometric perfection. While most planetary nebulae resemble delicate, wispy smoke rings or chaotic splatters of stellar material, this one forms an almost perfect X-shape, framed by vivid red lines so straight they could have been drawn by an interstellar architect. What makes this nebula truly baffling isn't just its structure, it's the physics behind it. Planetary nebulae typically form when aging stars shed their outer layers, creating expanding shells of glowing gas. But those ejections are supposed to be messy, shaped by turbulent stellar winds and magnetic fields into asymmetrical blobs. The red rectangle defies all of that. Its symmetry suggests something far more precise is at work, like a dying star spraying material in controlled, opposing jets with clockwork precision. The leading theory points to a binary star system at the nebula's heart, where two stars orbit each other in such tight synchronization that their combined gravitational dance sculpts the outflowing gas into these extraordinary shapes. Imagine a spinning garden sprinkler, but instead of water, it's flinging star stuff into space in perfectly aligned streams. Even more bizarre is the nebula's vibrant red hue, caused by a rare form of carbon-rich molecules scattering light in a way never seen elsewhere in the universe, like cosmic stained glass glowing under a hidden spotlight. Yet for all we've pieced together, the red rectangle still guards its deepest secrets. Why haven't we found more nebulae like it? Is this geometry a fleeting phase, or could it hint at entirely undiscovered physics governing how stars die? Every observation deepens the mystery, revealing intricate ladder-like rungs within its structure that no current model fully explains. It's a reminder that even in death, stars can create art that challenges our understanding and leaves us wondering what other impossible shapes might be hiding in the cosmos, waiting to redefine the boundaries of the possible. For decades, astronomers faced a cosmic accounting error that baffled the brightest minds where was half the universe's ordinary matter hiding. Theoretical models told us how much hydrogen, helium, and heavier elements should exist, but telescopes could only spot about half of it. This wasn't the elusive dark matter, but the very atoms that make up stars, planets, and even us. Scientists jokingly called it the missing Baryon problem, as if the universe had misplaced an entire ledger of its building blocks. The answer, when it finally came, wasn't found in some distant galaxy or exotic object. It was hiding in plain sight, woven through the vast emptiness between galaxies in filaments so faint they'd slipped past our detection for years. The breakthrough came when astronomers turned their attention to the cosmic web, the sprawling network of gas and dark matter that connects galaxies like threads in a tapestry. Using a clever trick involving distant quasars, the universe's natural flashlights, researchers detected the fingerprints of ionized oxygen in these filaments. The gas was hotter and more diffuse than anyone expected, stretching millions of light-years across the void and glowing just enough to betray its presence. Imagine searching for a whisper in a hurricane. That's how delicate this signal was. Yet when they pieced it all together, the numbers finally added up. The missing matter had been there all along, hiding in these nearly invisible tendrils of million-degree plasma, too faint to see directly but collectively containing enough mass to solve the puzzle. What makes this discovery so groundbreaking isn't just the resolution of a decades-old mystery, it's the sheer audacity of how wrong we were. We'd assumed ordinary matter would clump where galaxies clustered, not drift lazily through the emptiest parts of space. Yet there it was, the universe's lost inventory, hiding in the last place anyone thought to look. It's a humbling reminder that even the simplest assumptions can lead us astray, and that the cosmos loves nothing more than to surprise us. And as our tools grow sharper, who knows what other overlooked threads of reality might finally come into view, rewriting the story we thought we knew. These 20 cosmic revelations aren't just footnotes in a textbook, they're wake-up calls from the universe itself, reminders that reality outpaces our wildest imaginations. Every time we think we've mapped the limits of what's possible, the cosmos throws another curveball, dissolving the lines between science fiction and scientific fact. Take a step back and you'll see something extraordinary. Each of these discoveries, from diamond planets to zombie stars, isn't just a solitary oddity. Together, they weave a larger story about a universe that thrives on defying expectations, where the rules we hold sacred are merely suggestions waiting to be rewritten. What's truly exhilarating isn't just what we've uncovered, but how these findings ripple through science. A single observation, like that runaway black hole painting trails of newborn stars, or a pulsar spinning faster than physics should allow, doesn't just solve a puzzle. It shatters the puzzle box entirely, forcing us to rebuild our understanding from the ground up. And that's the beating heart of astronomy, not just collecting answers, but learning how to ask better questions. Here's the thing, we're standing at the edge of an uncharted era. Telescopes like James Webb are peering deeper into space and further back in time than ever before. Gravitational wave detectors are tuning into the whispers of colliding black holes. Every tool we build is a key to unlocking doors we didn't even know existed. Who's to say the next discovery won't rewrite the laws of physics again? Maybe it'll be a planet with rings larger than its star, or a galaxy younger than the stars it contains. Or perhaps something so bizarre we lack the vocabulary to even describe it yet. That's where you come in. The story of space isn't just for scientists in lab coats, it's for anyone who's ever looked up at the night sky and wondered. So hit like if these cosmic mysteries blew your mind, subscribe to join us on the next adventure, and drop a comment below which discovery left you the most stunned. The universe isn't done surprising us. Together, let's keep chasing the next great enigma, because out there in the vast unknown, the next revelation is already waiting.